Hey kids, we are back and we're learning what is known as completing the square today. I know you're excited. You've just been hearing about it and demanding it all year. When are we going to get to completing the square? When are we going to get there? Finally, kids, we're here. So rest easy, and hopefully it lives up to all the hype that you've heard about on the streets. So just to warm up to see where it kind of comes from, let's start with what we should already know here. Let's factor these two trinomials. Now there's no GCF I can take out in factoring. You would look for that first. It's just x squared, a trinomial with just x squared, no a value in front other than 1. So you really shouldn't need to use the AC method for this. You should be able to just say, hey, what multiplies there? That's going to be x and x. And what multiplies to positive 25 but adds up to positive 10? And that would be plus 5 and plus 5. Or, and that happens once in a while, or as we could write, if it's the same factor twice, we could write x plus 5 squared. Okay, so either of these would be a perfectly good answer, but this is what we call a perfect square trinomial. Just like a number that's a perfect square can be expressed as something squared, well, this trinomial can be expressed as x plus 5 squared. So it's a perfect square. And we're into like what makes these things be that, noticing the patterns. So x squared minus 14x plus 49. Is this another perfect square trinomial? Well, we got x and x. 49 is a perfect square. That's one of the properties you need. What multiplies to positive 49 but adds up to negative 14? Negative 7 and negative 7. So you could express this as x minus 7 quantity squared. Okay, because now we're going to use that idea to find the value of c that makes each expression be a perfect square. So for example, if I had covered up this 25 and said, what number would be here, would you be able to figure out from that 10 that it must be 25? And so really that's the idea here, is think about this 10 comes from 5 and then 5 squared, or 5 times 5, gives you that 25. And this 5 is half of the 10. Same deal with negative 14. Half of negative 14 is negative 7, and when you square negative 7, you get positive 49. So that's really what you want to look at, is look at this b value in the middle, and the b value is 12. So what do? Take 12, divide it by 2, and then I'm going to square it. So that would be 6 squared, and that's 36. So that's what c is. c is 36. And now it says to write the expression as the square of a binomial, meaning then actually factor it. So if you want to take a step and rewrite it as, hey, it's x squared plus 12x plus 36, and now factor that, can you go right to this step right here? I think you probably can, of that must be x and x, and what multiplies to give you that 36 and also adds up to 12? Positive 6. And you see that positive 6 really just comes from right here, that whatever you did when you did this b divided by 2. So there are really two answers to that. Find the c, then express it in factored form. This one right here, if you've got negative 18 in the middle, what's going to be on the end here? If you need to do this part in your head, that's totally fine. You take negative 18 and you take half of it, and then you're going to square that. That's going to give you your c value. Now you get negative 9, but of course, even when it's negative, if you square, you get positive 81. Right? Just like this one right here. Even though it was negative 14 in the middle, you have positive 49. So c is 81, and now express that in factored form. So if there was a plus 81 there in place of c, what would this factor to? That would be x minus 9, right? What multiplies to positive 81 adds up to negative 18, negative 9 and negative 9. And again, it's whatever you did by dividing that b by 2. Negative 9, that's going to be what's in the factors there. And so this really works nicely, and if that number in the middle is even, what if it's an odd number? And it might seem a little uglier, but by now you shouldn't be too worried about fractions and decimals, non-integer answers. So our C value, same idea. You take whatever's in the middle here and you're going to take half of it. That's going to tell you which is in each factor, and then you'll square it to get the C value on the end. So now if you wanted to call this negative 3.5 and then square it, that's totally fine. You could use a calculator. That'd be fine. Really nice to square it in fraction form though, because I know the negative squared will be positive, and then you just square the top and bottom. 7 squared, 49. 2 squared, 4. So 49 fourths. If you did the decimal negative 3.5 squared, that's probably harder to do in your head, but you would get 12.25, which is just the decimal version of that. Also, you know, perfectly good if you like. And then in terms of factoring it, now this would be kind of a weird thing if I put this in front of you and said, hey, factor that, or if I put 12.25 there and said, hey, factor that, you wouldn't immediately recognize that. So this is where you've got to trust your your patterns a little bit. That really all it is whatever this number is divided by 2, this negative 7 halves, so, or negative 3.5 if you like. That's what's going to multiply to positive 49 fourths and add up to negative 7. All right, so there's one idea. That's called right there. That process is completing the square, because you found the number that completed it to make it a perfect square trinomial. And we'll see what it's used for, or at least one of the things it's used for. And this is just to review this. This is what we've been working on last week. So solving an equation when you have this quantity squared. Okay, no problem. I'm going to take the square root of both sides to get rid of that. And you can't just square each thing in there, and you don't really want to FOIL this out. If you have this, take the square root of each side. So x plus 7 is equal to plus or minus. Remember, there's going to be those two solutions. The square root of 25. It works out nicely that that is a perfect square, so you have plus or minus 5. And so remember, this is really two separate equations, if you like. This is x plus 7 equals positive 5, and x plus 7 equals negative 5. And then you're going to subtract 7 either way. But notice you get two entirely different answers. You get negative 2 and negative 12. Right? So don't just say, oh, 5 minus 7 is negative 2, and I get plus or minus 2. No, you get two very different answers, so take your time and think about that, or actually write two separate equations. All right, and what about this? X minus 3 squared equals 12. Take the square root of both sides, plus or minus the square root of 12. Not a perfect square, no problem. What does it reduce to, though? Root 4 times root 3, the square root of 4 is 2, so we have x minus 3 equals plus or minus 2 root 3. And to solve for x, I'm just going to add 3 to both sides. And I'm not going to bother making two separate equations here because I'm not going to be able to combine these anyway. They're not like terms, so I'm just going to write it's 3 plus or minus 2 root 3, or plus or minus 2 root 3 plus 3 if you want to put the plus 3 on the end. But since I can't go any further, I'm just going to leave it like that. If you did want to write them separately, that means 3 plus 2 root 3 and 3 minus 2 root 3. But that's that. Okay, so that was a review on this. This was new, and now we're going to put them together. And this is really what it's all about. And I suppose I could have just started with this, but I feel like it makes more sense if you kind of cover what you already know. So what it's really used to do is solve equations. Now, solving quadratics, you know two major ways. Your first way is to check for factoring, and to me that's still the best and fastest way. And if that fails, the one way that works all the time is quadratic formula. You know, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And that works whether it factors or not. So you got two ways, and one way will work no matter what. Completing the square is actually a third way that will work any time also. So it's not necessary to know it, but it does some other things in math. So it's good to see it at least. And some kids like it better than quadratic formula. So taking a look at this, it's all equal to 0, which is great. Ready to go for quadratic formula or factoring. If you were to try factoring, you would have to do AC method here. 3 times 15 is 45. And does anything multiply to 45 and add up to negative 24? It'd have to be negative and negative, negative 9, negative 5, negative 15, negative 3. No, there's no combination. So you'd have to use the quadratic formula here, or this new method I'm about to show you, which is completing the square. So check this out. If you do completing the square, step 1 is to isolate the constants. And that means if you have any constants here, move them to the other side. And if you had any non-constants here, you want to bring these over. So I'm going to subtract 15 from each side. So there's step 1. 3x squared minus 24x is equal to negative 15. All right, so I've isolated the constants on the other side of the equation. Step 2 is to make your a value equal 1. So right now a is 3. It's nice when it's already 1, and sometimes it is. Right now it's 3, so what am I going to do? I'm going to make it be 1 by dividing by 3. Now just keep in mind you've got to divide everything in the equation by 3. And I could have done this first actually, just so you know. These first 2 steps, they really could be interchangeable. But now I have x squared minus 8x. Now watch, I'm going to leave a little space here because I'm going to do something in a minute. This is sort of planning ahead here when you get good at completing the square. And over here is negative 5. So here is where, step 3, I'm going to complete the square. And that's that process that we were doing. Make this be a perfect square trinomial on this side where it says, plus c. Find that c, what it is, and add it to both sides. So this is where you're going to take the b, and you're going to do b divided by 2 squared, and add to both sides. So I'm going to take this amount. So this is where, I like to say, think about it like this. I'm going to add something here, plus blank. That's why I was leaving a little space here. So we're going to complete the square. But whatever you add to one side of an equation in math, you got to add to the other to keep that balance. So here's where we're going to do that little trick. And using this negative 8, the b value, divide it by 2, you get negative 4. And then take negative 4 and square, and you get positive 16. Now if I add positive 16 here, I've got to add positive 16 here. And now, I guess I could simplify that a little bit. You got x squared minus 8x plus 16 is equal to negative 5 plus 16 is 11. Now is where you're going to factor and solve. Now what I mean by that is, on this side, if you've made it a perfect square trinomial, factor it as a perfect square trinomial, leaving this as 11 over here. And this is x minus 4. Remember, it's whatever that number is divided by 2 before you squared it, or in other words, what multiplies the positive 16 and adds up to negative 8. It's negative 4 and negative 4. So it's a perfect square trinomial. We factored it that way, and you see what you just did was you made these equations that we've been working on solving. Now I can take the square root of both sides. So x minus 4 equals plus or minus the square root of 11. 11 is not a perfect square and doesn't reduce. And now add 4 to both sides. So x is, add 4, 4 plus or minus square root of 11. And you see we have a radical left over. That's an irrational answer. That's because it didn't factor. Whenever it doesn't factor, you're going to get radicals or decimals. And that's exactly what I would get from the quadratic formula. So it's kind of a cool process to avoid the quadratic formula, if you like. So let's just take a look at 2 more examples of this. It's a little confusing at first. It's not something you would just think to do on your own, but it's a pretty cool method, and some kids like it better than quadratic formula, actually. So just all about giving you options here. It's nice to have more than one tool in your toolbox. So we're going to run through these procedures again here. Number 1, isolate constants. So negative 1, move that to the other side by subtracting 1. So you have x squared minus 6x. I'm going to leave a little space here, and I'm just planning ahead. And over here, 0 minus 1 is negative 1. And by the way, notice this did not factor. Nothing multiplies to 1 and adds up to negative 6. Yeah. So here's where we're going to complete the square. Because our a value is already 1, and that's what you want to check for. So if that's not 1, you got to divide through by whatever it is. And now I'm going to plus blank plus blank. What's the c value that makes this be a perfect square trinomial? Negative 6 divided by 2 is negative 3, and negative 3 squared is positive 9. Positive 9 here means you got to add 9 to this side to keep that balance. And now we factor it. On this side, this is going to factor to x minus 3 squared, right? What multiplies the 9 adds up to negative 6, negative 3 and negative 3. Or in other words, just half of that b, negative 3. Over here, negative 1 plus 9 is 8. And now you've got this quantity squared, take the square root. X minus 3 is equal to plus or minus the square root of 8. 8 is not a perfect square. What does it reduce to? Root 4, root 2, the square root of 4 is 2. So we have x minus 3 equals plus or minus 2 root 2. Add 3 to both sides. And these are not like terms, so 3 plus or minus 2 root 2. Done. If you wanted to get the decimal approximations, you could do 3 plus 2 times the square root of 2 and 3 minus 2 times the square root of 2. And those decimals should be the same thing if you graphed this on Desmos and said, where does it equal 0? Where does it cross the x-axis? It would be at these 2 decimal values. So kind of cool. That's still what you're finding when you solve this, are the x-intercepts or the zeros. And just one more if you're looking to see one more, you want to see if you want to pause and see if you can do it on your own. Subtract 55 from each side, subtract 55. Okay, so we have x squared minus 12x. I'm going to leave a little space here for my completing the square step. 5 minus 55 is negative 50. And a is already 1, which is good, so I don't have to divide through. Plus blank plus blank. Now let's complete the square. Negative 12 divided by 2 is negative 6. And then we square that. Negative 6 squared is positive 36. Positive 36. Now notice, when you square, you're going to get a positive, so don't make a silly mistake. And over here, we got x squared minus 12x plus 36. That's now going to factor to x minus 6 squared. Over here, negative 50 plus 36 is negative 14. And now to solve this, I'm going to take the square root of both sides. So x minus 6 is equal to plus or minus the square root of negative 14. And hopefully you stop right now and you say, whoa, whoa, whoa. You can't take the square root of a negative number. That's what we call imaginary. That's what you'll be learning about in Algebra 2. But for right now, we say, hey, no square root of a negative. This means no solution. Or if you were to look at this graph, where does this graph equal 5? Or if you brought this all to one side and said, where does it equal 0? It would not touch the x-axis at all. There would be no intersection between these two graphs. So there we go. You can get these imaginary solutions, these no solutions. So you just stop right there at this level, and that's that. And so just watch out for that. Any other questions, please ask. Please just let me know. Otherwise, good luck, and we'll see you soon.